Hola, Mr. Sutton here with the Pre-Cal Honors 6-2 Extra Practice Number 2 solutions on vectors. To get the component form of the vector that has these 2 points, we basically have to get directions from point A to point B. We can do this by essentially subtracting point A from point B. So we'll do this one coordinate at a time. For the x values, we're going to have 6 minus negative 6, so 6 plus 6. And then we'll have 2 plus 6 or minus negative 6 for the y values. So that's a component vector of 12, 8. Now to get this absolute value of AB, which is the magnitude, we're finding the length of the vector, so essentially using Pythagorean theorem on 12 and 8. So we're going to have the square root of 12 squared plus 8 squared. That's 144 plus 64, which is 208. And let's see, I know 4 goes into that. 4 times 52, and 4 also goes into 52 13 times, so that means we could have been doing 16 times 13, which means this can be reduced to 4 radical 13 when all is said and done. For this problem, we're trying to do negative 3u with a vector with this component form, so I'm just going to substitute this component form for u in this expression. We've got negative 3 times 7, 11. And then we just have to distribute this negative 3. So that's going to give us the vector negative 21, negative 33. For this problem, given these 2 vectors, we want to figure out u minus v. So let me substitute the component forms in. We've got negative 7, 9 minus negative 1, 4. And I'm going to just subtract the x values and the y values separately. So combining this, we really have negative 7 minus negative 1, or plus 1, 9 minus 4. So that's going to end up being negative 6, 5. On this problem, we're trying to figure out negative u plus v for these 2 vectors. Let's replace the letters here with the component forms. So we've got negative 11, negative 4, plus v, which is 9, 12. I'm going to distribute this negative first, so that's 11, 4, and then we're just going to add the x values and the y values separately. So we've got 11 plus 9, 4 plus 12. So that's then going to be 20, 16. For this one, I'm trying to do 5u minus 5v for this pair of vectors. Let me put the component forms there instead of the letters. So we've got 5 times this first vector, negative 2, negative 5, minus 5 times negative 1, negative 2. For my next step, I'm going to distribute those constants outside the vectors. So for this first one, we've got negative 10, negative 25. And for this next one, I'm going to just distribute a 5 in here and keep a minus outside, although you could distribute a negative 5, either way. So I'm going to end up with a minus, and then inside the vector, I've got negative 5, negative 10. At this point, I'm going to just subtract the x's and the y's separately. So I've got negative 10 minus negative 5, so negative 10 plus 5, and negative 5 plus 10, or negative 25 plus 10. So negative 10 plus 5, that's going to give me negative 5 for the x value of my final vector, and for the y value, I end up with negative 15. For this one, I want negative 9u minus 2v for these 2 vectors. Let me put the component forms in there. So we've got negative 9 times negative 11, 7, minus 2 times 8, 12. Distributing those numbers outside, we end up with the vector 99, negative 63. And for this next one, I'm going to keep the minus outside. Inside, I'm going to have 16, 24. Now I'll just subtract the vectors. Let me do the x's and the y's separately. So I've got 99 minus 16 and negative 63 minus 24, giving me a final vector of 83, negative 87. On this problem, I'm trying to do negative 10u plus 6v for these 2 vectors. So let me just plug in the component forms. I've got negative 10 times 10, 1, plus 6 times 7, 12. Distributing those scalar factors outside, I've got negative 100, negative 10, plus 42, 72. And now let me just add the x's and the y's separately. So we have negative 100 plus 42, comma, negative 10 plus 72. Negative 100 plus 42, that's going to be negative 58. And then we'll have comma, this will be 62. To find the dot product on this one, we need to do the product of the x's and the y's and add them together. So I've got 7 times 9 plus 4 times 2. So that's 63 plus 8, which comes out to 71. For this problem, I'm taking the dot product of these two vectors. So I've got 6 times 4 and also negative 3 times 5, and I'm going to add those two products together. So 24 plus negative 15, which is going to give me positive 9. To find the dot product of these two vectors, I have to multiply the x's and the y's separately and then add those two products together. So I've got negative 4 times 9 plus 5 times 6. So that's negative 36 plus 30, which comes out to negative 6.